What's up, nerds? It's your math teacher, back at you with video 5, sector area and radians. Are we not excited for this? I know I am. Let's get started. Woo! Let's do a little bit of review all the way back to geometry. I want to talk about sector area, and I want to look at the formula, but also solve a problem. So let's go ahead and let's say that we have 60 degrees right here. Okay, and we've got a radius of 5 inches. When I'm asking you for the sector area, what I'm asking you for is the area of that pizza slice. So this formula right here tells us that we have to take our angle, theta, and plug in, and same thing with our radius. So let's see what that looks like. That's area equals 60 degrees divided by 360. I like to put parentheses around there and then do pi r squared. So in this case, we have pi 5 squared. All right, what does that look like? That actually looks like the following. It looks like 0.1666, and then we've got pi 5 squared, or if you want to say pi 25, let's keep it as 5 squared for now. And the answer to this is 13.089. And since we have inches right here, I'm going to say that we've got inches squared or squared inches because we are talking about area. Although this is nice that we can do this, what I'm actually more interested in is this, which is this, or this. What have we found here? I want you to look at the 0.1666. That's being multiplied by pi 5 squared, which is the area of the circle. So really what's happening here is this 0.166 is the part, or 60 degrees, over the whole. Well, what is part over whole? That's a percent. So this 0.166 here is actually a percent. Specifically, that's 16.66%. We're finding 16.66% of the whole area. That's important for us to know when we talk about the formula using radians. So let's remember that. All right, here we are. If we're thinking about area equals 1/2 r squared theta, where theta is in radians, let's go ahead and let's think about what radians are here. Well, if we're talking about theta, we're talking about 2 pi. So really what we have here is that the area is going to be whatever the radians end up being over, well, before it was 360, what's the equivalent of 360 here? Well, that's going to be not 360, that's going to be 2 pi. And then we're still going to do times the area of our circle, pi r squared. Well, what kind of things are canceling here? Certainly the pi's. And let's kind of go down here and say, what can radians be represented as? Well, obviously theta. Okay, and I'm going to divide that by 2, and now I've got an r squared. Now let's simply simplify this by pulling out the divide by 2 as a 1/2. And next, let's write the r squared. And finally, let's write the theta. So here's our formula for finding the area of a sector using radians. So this right here, this theta, should be in terms of radians. All right, let's do an example problem. We're going to find the area of this sector given that we have pi over 4 as our angle, which we know is 45 degrees, and we have a radius of 4. So let's mark our picture. We've got a pi over 4. we've got a radius of 4. And let's call this inches as well. All right, let's use this formula. We have area equals 1/2 is first. Okay, I'm getting that from these formulas down here. My r squared is going to be 4 squared. And my theta is pi over 4. Simplifying that, we have 1/2 16 times pi over 4. Well, what's 1/2 of 16? I'm going to do this right here. Half of 16 is 8. And then we've got to rewrite our pi over 4. Well, what's 8 divided by 4? That is 2. And we are left with 2 pi. And of course, we are talking about area, so we're going to have that as inches squared or square inches, however you'd like to say that. Awesome. Should we try one more? I guess so. Let's try this now. Let's try this now with a different radian. Let's go with an angle of pi over 2. And let's do a radius of 2. So marking this picture now, we are at pi over 2 and a radius of 2, let's say inches again. All right, here we go. Let's plug right in. This is going to be area equals 1/2. My radius here is 2. I'm going to square that times my pi over 2. Simplifying this, we get 1/2 of 4 times pi over 2. Well, what's half of 4? It is 2. I got to keep my pi over 2. My 2's cancel, and I'm left simply with pi, bringing our units back in, square inches. There we go. Okay, now we're going to work backwards. So what do I mean by that? That means I'm actually going to give you the sector area, and I'm going to ask you to work backwards. Given the sector area and the radius, I'm going to ask you to find the angle, but I'm asking you to find the angle in radians. So let's start this. Let's say I tell you we've got a sector area of 3 pi inches squared, and the radius is 6 inches. First step we always do here is write our formula. This is going to be A equals 1/2 r squared theta. Well, my A is 3 pi. I don't need my units, just write 3 pi. Then I'm going to have 1/2 my radius squared, which is going to be 6 squared, times theta. Let's go ahead and simplify. We've got 3 pi, keeping that, 1/2, 6 squared is 36, theta. What's half of 36? You betcha, it's 18. So we've got 3 pi equals 18 theta. Let's divide by 18. The 18's cancel, and I am left with theta equals 3 pi over 18. Now you can throw 3 divided by 18 into your graphing calculator, press math and then fraction, or you could say to yourself, oh, both of 3 and 18 are divisible by 3, so if I want here, I can go divide by 3, and that's going to give me a simplified answer of theta. 3 divided by 3 is 1, or I can just write this as pi. 18 divided by 3 is 6. So we just found that that angle was actually a pi over 6. Shall we do another problem? I think so. Let's go ahead and let's say that the area is now 128 pi over 3. Call that inches squared, and our radius is 8 inches. So again, let's write our formula. A equals 1/2 r squared theta. Plugging in, we get 128 pi over 3 equals 1/2 8 squared theta. Let's go ahead and do 8 squared. 8 squared is 64. Okay, so this here is 64. And then taking half of 64, halving 64, I get 32. So I'm going to rewrite this down here as 128 pi over 3. Again, half of 64 is 32. So this becomes 32 theta. All right, next step, what I would do here is I'd multiply by 3 on both sides. Times 3, times 3. The 3's cancel. And so now I get 128 pi equals 32 times 3. Okay, 32 times 3 gives me 96. Don't forget my theta. Last step here is divide by 96. 96 cancel, and I am left with theta equals 128 over 96. Don't forget my pi. And you could go ahead and throw that into your graphing calculator, do math fraction, and I find that that does reduce quite a bit. In fact, it reduces to 4 pi over 3, and that's equal to my theta. And so we're all done with that problem right there. That's it for video 5, ladies and gentlemen. Thanks for watching. Don't forget to do your assignment. Also, don't forget to brush your teeth and wash the dishes. Have a great day.